Y'all can't even see that because somebody's I don't know. All right, here we go. This is a lot of information, but it's not bad. Okay, but it's just a lot of information. And y'all, if you don't want to write something, like while I'm gone, if you're here, the geometry books, this is in those geometry books. It's chapter 7. Okay, just go to chapter 7, and this is lesson 2. It's lessons 1 and 2. So like if you need to look at a picture, go grab a geometry book, just return it. Or if you take it home, return it or whatever, okay? Or just watch the video, okay? Or you can write it down. But this is what I started talking about yesterday, similar polygons. I think I was talking about triangles being similar. We did ratios and proportions. Now, they're similar if they have that same shape, but they can be different sizes. What you'll notice is all the angles match. Do y'all see that? If the angles match, they're going to have the same shape. Okay, so if the angles match, they're the same shape, but they could be different sizes. See how this one's really small and that one's big? But they're similar, aren't they? Because they have the same shape. So if the angles, and look, notice, let me see if I can zoom in and clear that up just a little bit. Notice that little squiggly line. It's not congruent. Do y'all remember the congruent symbol looks like this? That means it's kind of like the equal sign for geometry. That's congruent. It basically means that they're equal. Okay? This is just a single squiggle. That means they are similar. They are not equal. Like, say that this one's measurement is 2, well, this one is 4. Okay? Are those the same?
No.
But they're similar, right? That's what the little squiggle means. That means, okay, these are similar. Now, what we do know about similar polygons is that the angles are congruent. Okay, so you can use that congruent symbol for the angles. Like A and G are congruent, D and J are congruent, C and I and B and H are congruent. Does everybody get this? That's the angle part. The other part about being similar, okay, is they're proportionate. So if this one is 2 and this one is 4, if this one is 3, any guess what that one would be? 6. Maybe 6. See how they're that's what this other part, it would be 6. Okay, what am I doing to this? I'm doubling it, right? If this one was 4, what would this one be? 8. Okay, and if this one was 5, this one would be 10. See, that's proportionate. Does everybody see that? They're not equal, but they are proportionate. That's what all these little symbols right here mean. Okay? And I'll show you how we'll figure that out in a second. But it's just saying that this side is proportionate to this side. This side's proportionate to that one. Do we kind of understand that concept? They're not equal, they are similar. So they are proportionate. The angles are congruent though. Okay, another word they have in here is the word scale factor. I don't know if y'all ever did that in 8th grade where you draw something to scale. A lot of times you'll use scales on maps. You know, it'll be like 1 inch represents on the map, it might represent 50 miles. Okay, so like when you're measuring how far in the old days when you didn't have phones, how far do we have to go? And you would just measure, oh man, that's 150 miles. Okay. Scale drawings or models are made, like buildings, right? Say that they want to model a building that they're going to have for somebody, some architect. Well, they'll build one and it will be modeled to scale. Model cars, have y'all ever seen model cars? Right? Those little bitty, they'll be like a model car of a fancy one. I used to have one of mine, but anyway, it would be tiny. It was proportionate though. It was a scale model. Okay. All right, let's look at some problems now. This right here says, oh, welcome, boys. All right. I'm trying to cover the answers. Okay, here's your 2 triangles. Now, they state what's similar. Notice the order matters. We remember this. We've done this with congruence before. Okay, now these are similar. So what are the pairs of congruent angles? their angles are congruent. What does M go with?
S.
Angle M is congruent to angle S because it told me that it matches those together. Angle N is congruent with what angle?
Angle P, or angle R.
Angle R, and then angle P is congruent
Angle
to
T.
angle T. That's your congruent angles. Is everybody okay with that? All right. Then it says on the next one, what are the proportions for the ratios of corresponding sides? Like what sides go together? I'm going to erase these angles. They're listed right there as well.
MN goes with SR.
So MN goes with SR. Very good. And that would be the same, it's going to be proportionate to what are some of the others? How about NP?
NP goes with NR. Or not NR, RT.
RT. I'll explain in a second if you're not getting this. And what's the last one?
RT goes with.
Well, I did RT.
Oh, sorry.
I did MN, I did NP, so I need to do MP.
Okay.
MP goes with ST. Now, I didn't even look at the picture. Boys, y'all pay attention. I didn't even look at the picture. Did y'all look at the picture to see? I just looked at the way they listed it. Okay? I just saw, okay, MN, that side, right there. What side does it go with? SR, which would be that one. Okay? I'm not going by my picture. I'm going by what it gave me. Does everybody understand that? And then the next one, and these things are not, the sides are not equal. The sides are proportionate. Okay? And then they are all, the proportions are equal. So, NP goes with RT. I just looked at the last two, so it goes with those two. All right, if I looked at that, whereas NP is this one, RT is that one. Okay? Do we kind of get that? Just making a proportion. We are about to do that with numbers. So if you don't understand, I think that's part of your worksheet, the first part of your worksheet for Thursday. And maybe it's on the worksheet for Friday as well. Probably saying what angles go together and write the proportions. That's how you would do that. Do we need another one of those? Anybody? Yes? Are you sure?
I'm sure.
Okay, then we will go to, this one. I'm not sure. Okay, it says, are the polygons similar? If they are, write a similarity statement. So, let's first of all check all the angles. And then we'll have to write a similarity statement. Okay, that's part of it. Let's check all the angles. This one checks out. That one is 90. That one has 3 marks. That one has 1. First step is checking that all the angles match a congruent angle. Do we get that? So I think they're going to be similar. What else do we have to check? That each side is proportionate. So how do I do that is I'll just start with this one. What does the 12 go with?
6.
The 6. So 12 over 6. Okay. What does the 24 go with?
16.
Okay. I can already tell
They're not.
they're not. That's going to divide to 2. Is that going to divide to 2? They're not proportionate then. Like the pieces have to equal. I'll still finish going though. 24 would go with 14. And then the last one says 6 would go with 6. Well, that equals 1, that equals 2, and that equals somewhere in between. Does that make sense? They all have to be equal to each other to be proportionate. So they're not similar figures. Okay, so no, they're not. So we will not write the congruent statement. We would just say, these are not congruent. Okay. The angle, it says they're not similar. All right, they kind of did theirs different. They wrote it different. Okay, this one. It wants to know, can they see that? I'm trying not to cover that up. That'll work. Okay, are these 2 triangles similar? So first thing we check are all 3 angles. I've got 1, 2, 3, 1, 2, 3. We're good to go on that. Everybody, okay? So now let's look between the 1 and the 3. That's 20. What is this one?
16.
16. So I'm going to put 20 over 16. See how I'm matching them? We have to match them, okay? So let's look between the 2 and the 3. What is this one? 15, and this one is 12. So let's see if all this is gonna equal. And the last one, if I'm starting at the one on the right, I have to do that every time. This one is 10 and that one is 8. So if I reduce all these numbers, what does 20 over 16 reduce to? Divide them both by 4. Wouldn't that be 5 over 4?
Yes.
Divide both of these by what number? 3. What's that going to be? Okay, divide both of these by 2. What is that going to be? Okay, so are these similar? Yes, because they're proportionate. If you don't know how to reduce, type it in your calculator. 20 over 16, math enter enter. 15 divided by 12, math enter enter. Okay, it'll tell you. And anyway, that's all you're checking. Yes, they're proportionate. So now it says write a similarity statement. What is that?
Isn't that what you did?
So, well, no. I found that they're proportionate. I think it says give, I don't know. I'll see what else it asks in a second. It's way up there at the top. Let me write the similarity statement. Triangle is similar to whatever. Okay, so which one? Y'all want to start with A, B, C? Triangle, I wrote that wrong. A, B, C, this is where the similar sign goes, is similar to triangle. Now let's just make sure we go in the right order. I'm going 2 to 3 to 1. So I'm going to go D, E, F. That's a similarity statement. Okay? Is everybody good with that? Now, then I think it asks for something else. Let me see, did it ask for something else? Oh, give the scale factor. Now, y'all, I actually did this backwards. I got 5 to 4. Does everybody see my scale is 5 to 4? But I started with what triangle? That one. So what should my scale be? 4 to 5. Like I should have started with this one. I think in the past, if they did 5 over 4, if you showed all this work, you would still get it right. Okay, but the reason it's 4 to 5 is because I start with what triangle?
What do you do if you only have numbers on two sides?
Let's see. What number are you on? 2?
4.
You're I'm not there yet. I'm getting there. I think you can use side angle side is what it is. Let me see. I don't know. All right, let me check this next one. Let me do another one, and I'm going to go in the right order this time, just to make sure we're clear. Okay? Because we have time. We're not even doing a paper today. So, do y'all want me to do the one on the left or the right? Left. Okay. So let's see if these are similar. I was about to say congruent. Now, be careful here because I need to make sure they're turned the right way. Does everybody understand that? So all my angles are good to go, right? So let's look at this side. I'm wondering on that one. Oh, since it's showing it's a rectangle, so I know this is 15 and what is this? 10. This one's 20. This one's 15. Okay, does everybody understand that? How do you know it's a rectangle? Because they're all 90-degree angles. If they're all 90-degree angles, what is it? Okay, so let's see. This side goes, the 20, what does it go with? The long side is 20. It goes with what? 15. And, or actually, let's start with the one on the right. I mean the one on the left. Sorry. Let's go 10. I'm saying this all wrong. 15 goes with 20. Now let's start with the short side on this one. 10 goes with what? The short side on this one. 15. Okay. Now do those reduce to the same number? If I divide this one by 5, what do I get? 3 over 4. If I divide this one by 5, what do I get?
2 over 3.
So are those similar? No. I changed and I started with the one on the left, and I would compare them that way because I did it backwards last time. Okay, let me go ahead and do this one. All right, let's check. I've got angle 1, 1, 1, 1. That one has 2 marks.
So what do you call the other one?
Not similar. Or you'll just say, are the polygons similar? No. And you're done. Okay, now this one, all the angles have a matching angle. Does everybody understand that part? Now let's do all the sides. So I'm going to start with the one on the left, my A, B, whatever, A, B, C, D, E, and then do R, S, T, U. So A goes with which one? Let's see, this A, B, which one does it match?
UV.
A, B, you think it's UV?
No, it's
I mean, I guess it could be. I was just thinking, let's just
SR.
flip it around and do SR. So I'm gonna go 18 to 9. Does everybody understand that? Okay, let's keep going. Let's go with this longer side, 18.
8 to 9.
Or does that say? That is, no way that says 18.
It does.
It does? I guess so, yeah. And that would still work out. Okay, so it's 18 to 9. That one's 18 to 9. Then what's my next one?
18 to 9.
18 to 9. And then what's my next one?
12 to 6.
12 to 6. And then my last one.
12 to 6.
12 to 6. So is this going to all be the same scale? Yeah, what does that divide to? 2 to 1. Or 2. Does everyone understand that? It's 2 to 1. So you're going to say, okay, polygon, I don't know how to write the little polygon. I'm just going to say A, B, C, D, E is similar to what order? A, B. So be careful. I went A, B, C, D, E.
S, R, B.
S, R, B, U, T. Very good. I'm not sure what symbol they use for polygon. But does everybody understand that's a similarity statement? Are we good with these? Just seeing if they're proportionate. Okay. And some of these I'm thinking are like multiple choice on your worksheet. I can't quite remember. Now let's see what else we have.
We're doing our worksheet on Thursday.
This worksheet is Thursday,
Yeah.
and then a review of both of the days on Friday. Okay. The next one, I want to cover up the answers. Hey, I don't even see one like number 4, you said?
Yeah, just do it on the page then.
Number 4 or number 2?
Number 4.
2 is fine. 2 we just want
Number 4
to
has 2 sides. Like,
since the angle is the same, I guess y'all really haven't learned that one yet, but just set up the numbers, like or 10 and 12 or 12 to 10 and 18 to 15 or whatever.
What is number 2? You 12 over 24 and 4 over 8?
12 over
wait,
24.
That's not enough.
Okay, then do it a different way. If that one didn't work out, then try, what about 4 over 12 and 8 over 24? Do you see that one? No. So then try 12 over 4 and 24 over 8. See how I'm just matching? I'm trying to just see what pattern. All right, that one is 1. So you're just trying to see what pattern. Hey, number 4, just see if those 2 sides are proportionate. Because that one does work. Okay, now let me go with the next part. We're going to create proportions. So this says, okay, these are similar. So what is X? All right, that's what it tells me. These little polygons, oh, it doesn't give a symbol. It just names them. They're similar. So what is X? So I'm going to match pieces. All right. What am I going to match X with? What does X go with?
7.5.
Okay, so let's do X to 7.5. Is everybody good with that? Now I need 2 more pieces. I cannot use Y. I don't know what it is. So I need to find something else. What else do I know? X goes with 7.5. What about 6? What does it go with? 6, this little piece. So I did X and the long piece. 6 and the, what's that long piece? Y'all don't see it? Y'all don't see it. Okay, look. I did this short piece with this long piece, which is 7.5. If I do this short piece, 6, what's the long piece? 9. There you go. Okay? They just put the shapes together. If I need to redraw this one's 6. What's that one?
No.
9. Okay? It's all there. So now what do you do to find x? This was yesterday's stuff. Cross multiply. So I get 9x equals, what's 6 times 7 and a half?
42.
45. Okay, then what do you do? Divide by 9. So x is 5. Are we good with that one? Okay, just solving for x. That's all it wanted. What if I wanted to solve for y? Okay, let me solve for y. We'll have to set it up. What did I say? X is 5. We can use that now if we want to, or we can just use the 6 and 9. What does y match? What does y go with? 5. And in that same order, if I did y to 5, I'll do the smaller one. Okay, 5 to 7.5. Maybe y'all picked 6 over 9 again. That's absolutely fine. You would get the same answer, okay, because these are proportionate. So we get 7.5y equals 25. Divide by 7.5. I don't know what that is. 25 divided by 7.5.
3.33.
Okay, so 3 1/3 or 3.3 repeated. Okay, so there's that one. I don't even think it asked for that one. Let's see. Oh, it did. It gave it as an improper fraction. All right, now let me see some from the book that I might want to do. I think. There was one. I really want. I'm trying to find one like on your paper. Oh, here we go. I think this one will work. Okay, it says that these triangles are similar, so find the value of x. All right, find x, and then let's give the scale factor. It's kind of like some of them on your paper. So, what side does x go with? X is proportionate with what? So both of these are x. Now look at this triangle. So it's 5. Does everybody understand that x goes with 5? This is x and this is x. On this triangle, that's 5 and that's 5. Are we okay with x going with 5? So what does that mean? X plus 6 goes with what? What's the other side? 8. Then what do? Cross multiply. Be very careful here. We get 8x over here. And over here, what does 5 go with?
X plus 6.
Both of those things. 5 goes with x, and what's 5 times 6? 30. Then what do?
Combine your X's.
Combine your x's. So I get 3x equals 30, then what?
Divide by 3, and it's 10.
So x is 10. That's part of my answer. I think that's all it asks for on your paper. I'm not really sure. So x is 10. So what is the length of, this side is 10. What's the length of that side? 10 plus 6. What is 10 plus 6?
16.
16. So do y'all know the scale factor? Does anybody know? No? What would the scale factor? This one is 10 to 5. This one is 16 to 8. What's the scale factor? Well, so we got, look, 10 goes with 5, 16 goes with 8. What is that? What is 10 over 5 reduced to? 2. So 2 to 1 or 2. You can put 2 to 1, 2 over 1. It's a scale factor of 2. This one's double the size of that one. Do y'all see that? That's what scale factor means. Okay, let's do 38 just for a little bit more practice. Anybody writing? Yeah. For a second. Okay. I'm trying to make sure. I don't think it asks for the scale factor on here. like that. It just says find x. Okay, that's doable. That one's doable. That one is doable. All right, anybody still writing? No? Okay, then I'll do a scale drawing. Do y'all want me to do one more of these? Do y'all need me to do 38? Are y'all good? Y'all got this? Y'all are not gonna say, oh, we could do it without you.
No, I need help on number 9.
On yours? Okay, hold on. I'll look at that and see what that is. Is it similar to this or is that a scale drawing?
It's one where there's, I don't know.
Confusion?
Yeah, there's not enough numbers for me to do anything with.
Number 9 is the triangles, right?
Yeah, with the 5.
So 5x over 4. Oh, this is actually a really good one. Okay, so if I set this one up, okay, you're going to put 5x with, which one do you want to put 5x with? 5. Okay, you can set them up different. You can set proportions up different ways. You can put these two together as long as you put those two together in the same order. You can do that. But I'll keep going the way we've done it. 5x with 5. Okay, everybody's good with that. If I put 5x over 5, what does 4 go with?
X.
In the same order. 4 goes with x. So this one is a trick.
You cross multiply.
You cross multiply. So, but this is so doable. Y'all know how to do this. What is 5x times x?
5x.
5x
Squared.
squared. It's 5x squared. X times x is x squared. Okay? And then what's 5 times 4? 20. How do I solve for x?
Divide by 5x squared.
We'll divide by 5. So x squared equals 4. Now, how do you get rid of a square? What's the opposite of squaring something? Square rooted. What's this?
X is 2.
Yep, there you go. So that's your number 9 mark. That one was a little bit of a trick on there. Okay? So, are we good with that? I think that's the only one like that. Okay, and can I still, were you writing that, Allie? No? Okay, just making sure I didn't wanna.
Can you want my first and second page of them?
In just a second, let me just make sure I don't have anything else. All of them were doable. What about the scale factor? Hayden, was that one doable?
Easy.
Does anybody want a scale factor problem? Maybe?
I need help on number 9 and 10 on the go over one page.
On the review?
Yeah.
Okay, well, hold on. Let me just go over a scale drawing just in case. I know y'all are bored, but we're in class. That's what I'm here for. It says, okay, the length of the main span in the scale drawing is 6.4. Okay, so it wants us to find the actual. They give me, do y'all see how they give me a
Question, right?
scale, huh?
This ain't my question.
No, this is not your question. I'm just going over a scale drawing because there is one of these on there. They give you the scale. Let me make sure. On here, they give you the scale just like this. There's 2 of them. I'm going to go ahead and write that scale down, and then I'm going to see my next part. All right. 1 centimeter on here. Is everybody okay with that? 1 centimeter on my picture is actually equal to 200 meters. That I'm going to use that scale. Everybody good with that? Now, let me get my next bit of information. And your problem's going to say this like that on your paper. The next bit of information, it's in the word problem. It says, okay, the scale drawing part that I'm looking at is 6.4 centimeters. So y'all, I'm going to kind of come back up here where you can see that. It's 6.4 centimeters. Where does that go, in the top or the bottom? Look at what I've got. I've got centimeters in the top and meters in the bottom. Where does 6.4 centimeters go? The top. Just follow along with your scale. So I'm going to have 6.4 centimeters. So I'm looking for, what do I call this? X. There you go. All right. And you cross multiply. So you get 1x. That's easy for that. And what is 200 times 6.4? what is that?
1,280.
Yep, that's what I got. Okay, and that's meters. 1,280 meters. So the length of it is really 1,280 meters. Do you see how to set that up? Use your scale, and then put your other bit of information with your variable, and then just cross multiply. This one we didn't have to divide. Okay, so you'll have 2 of those. We're good? Alright, and that's all your papers for the rest of the week. Okay, now let me
9 and 10.
stop record. That's on the review?
Yeah.
I guess I won't stop record. I'll go ahead and
There's so much randomness to these ones.
so much randomness.
Yeah.
Oh, okay. 9.
It told me -3.
Okay, I'll go over number
Is it
9.
-3?
What told you -3?
My brain.
No, that's gonna be something you tried to use. Hey, don't be using no photo math. I'm gonna have to outlaw phones completely if y'all are using photo math.
I need help on that one. Number 9.
My brain.
Oh,
told
yeah,
me
wait for
-3.
it.
That was it.
Number 10's not bad. Number 9, is it bad? Yes.
Both of them
yes.
are
But
bad.
are we gonna go over it because we should know this from Algebra 1?
No.
Yes. Okay. If this looks hard to you and you know that you have this problem on Friday, I would write this in my notes or just watch the video. Either way, if you don't feel like writing, you could watch the video. But this is number 9 on Friday's paper. It's the quiz review. By the way, this is not on the quiz if and when we have a quiz. Okay? Because notice this paper I circled all over them. This one wasn't circled. But we're going to learn it because I put it on here to review. So, you're going to cross multiply. Is this yucky? We're going to multiply this times this. Let me write them like this. 9 minus 6 times 3m plus 1. Do y'all remember FOIL method? First, outer, inner, last.
We have to do that.
Yeah, so we need to, y'all don't remember it, so obviously we need to go over it. Okay. Anyway, that's the left side. So what's the right side? These two multiplied together. 3n times n minus 5. Okay, that one's not as bad. That one we just distribute. Does everybody see that that's FOIL method?
Wait, I don't have anything.
Okay, and that's distributing. I'll wait.
Wait, that was my least favorite part of algebra last year, and it wasn't even that bad.
That's what they're about.
It was just a lot.
It's and it's hard to remember all that now, like when you're not even in that class. It's like, gosh. Are we ready to keep going?
Yes.
Okay. Now
Why is 3n not in the parentheses?
because there's not, if it was like 3n minus 1, then it would have 2 parts. But see how it's only one term? It's not 2 terms. If it's one term,
Okay.
we're
keep
just
going.
distributing. Okay, will you ask the
Well,
question?
yeah, but you just said the same thing about them.
Well, it takes that many times before y'all get it. Okay, n times 3n.
I'm offended.
N squared.
3n squared. N times 1. N. 1n. Okay? Negative 6 times 3n. Negative 18n. And negative 6 times 1. Negative 6. Let's keep going. This one's not FOIL method. I don't have to distribute 2 things. I'm saying it for the 6th time. I'm just going to distribute it once. So 3n times n is 3n squared. And 3n times negative 5
Is
negative 15n. Okay. Now we combine like terms. This is fantastic because the n squares are going to cancel each other out. If not, we would have to factor and stuff like that. But we don't. So let me go ahead and rewrite 3n squared. What does this combine to? A negative 17n. Does everybody understand what happened there? 1n minus 18n is negative 17n. Now I can't combine these over here. Now let's move our n squared. What happens when I subtract 3n squared from both sides? They all cancel out. My n squareds cancel out. Fantastic. Negative 17n minus 6 equals negative 15n. Then what do I do?
subtract.
Add 17n.
Yeah.
So I get -6 equals 2n. Then what?
Divide.
Divide by 2, and what does n equal?
N equals -3.
N equals -3.
My guesstimation is right.
That would be your photo math or
Who's photomath?
whatever else it is. Whatever other app. You're not going to use that on your test, so make sure you know how to do all this.
Hold on.
Did you do all your papers using photo math, Hayden?
I've not.
Did you do most of them with photo math?
Did it on the one question. That was it.
Okay.
On my soul.
Oh my
On the
soul.
So Jackson.
Okay.
What are you doing?
Can I erase?
Because it's gonna be the it's gonna be
Everybody, this is your problem. So, anyway, y'all, that's your number 9. Do I need to go over number 10? 10 is easier. Hayden, you should be able to do 10. 10 doesn't have any
No, but
squares.
it's confusing.
Well, is it the full method?
No. Mm-mm. No.
It's too much Y's, and I didn't.
It's not too much y. It's way less y's than n's.
I don't love my freaking packet.
How many Y's?
No, there's
Happy
like,
joke.
no, it's,
on Facebook.
Hayden, the 12y, look, I'm not going through it. Hayden, look,
I'm
the,
looking.
the 12y goes on the side,
I know, but
And
I
then
ended up
five-
with like 40 or something.
times both of those. Did you get 12y
I got 15Y
minus
minus
40
40 equals
equals,
12Y.
then what do you do with the 15y?
I don't know.
Subtract it over.
But then it got me like -3, and I don't know what to do with -3.
Okay, so you get 40 equals
And then
-3y.
there was none of the answers on here.
Would you do minus?
Yes, it is. 40 equals negative,
There's no -3 on there.
that was it a negative, it's a negative 40 equals -3y.
I didn't get -40.
Because
Oh, because it was.
it's a minus,
So would
yeah.
it be C or D?
Yeah. Solve for
What?
y.
C or D?
It is.
Yeah.
Look, you got, look, Hayden.
This guy.
I said, would it be
You
C
gotta
or
be
D? And you
teacher,
said,
man.
yeah.
Yeah, it would be one of
You
those.
don't have to make
Negative
No,
40.
like I said, would it be C or D? Like I'm asking which
I
one
know
is
what you're
it?
asking, I'm telling you. How do you solve for y? What do you do? Divide by what? Okay, so which one of those looks like you're dividing by 3? C or D?
C.
I don't know, I'm not looking. You're gonna have to pick
Which
it.
one is on top? I don't never divide like that.
Yeah, you have to divide both sides by -3.
No, but I don't know which one goes on top.
Look, I divide by -3. What's in the bottom? What does that look like?
You would do this.
Sorry, acting like Jackson Hill.
This one?
Where does that look on the math? The other.
It was 3 over 40 or 40 over 3. He just had to write the steps out.
Yeah.
It's 40.
Yeah.
Emma, how did it go with that?
Okay, I'm stopping my video.
Miss
Like, I
Debbie.
did it halfway, my brain.
Get that on video. Get that on video.
Well, I'm not gonna tell you who you sound like.